Okay, well, good evening, everyone. For those of you who don't know me, my name is Mike Mogadam. Welcome to the September meeting of the Ottawa Centre of the Royal Astronomical Society of Canada. Thanks for all coming. It's a pretty good turnout. I'm really encouraged by this. I'm wondering if it's me substituting for Bill Wagstaff this month, or maybe it's the Mooney Night. I think we'll go for the Mooney Night, bringing out the people. So we got a full agenda here tonight. Let's see if I can do this right. Yay, I did. Okay, so right off the top, one of my favorite segments is the Ottawa Skies. Gary Boyle will be sharing what we can look forward to in September. Brief update from Sylvie on some 10-minute astronomy news update. Eric's going to talk about a trip that he had a couple of months ago. I think he referred to it a little bit in the past, in previous meetings. We went to Algonquin Park and visited the Brent Crater. A new fellow, Ryan Anderson, he's joining us tonight. Ryan is the chair of the Ottawa Society of the Canadian Ottawa chapter of the Canadian Space Society. I'm so sorry. And he's going to talk about Canadian satellites, the satellites that are in space that are Canadian origin. Then we're going to have a break, and after the break, and as of course door prizes, and there's some really nice door prizes I might point out. Al Scott is going to recognize some of our members with some membership pins, and after that, there's a whole suite of observations. I think you're going to be quite encouraged by that. And then to finish the meeting, we've got a talk that Al Scott did a couple of months ago at the Cube Gallery, where he was one of the invited speakers to talk about. One of the invited speakers, and his subject is possibly life on other planets. So, before we get started, what we usually like to talk about is the Ottawa Centre members in the news. Now, Deborah and Peter, are you here tonight? I didn't see you. Cerebello? So, Deborah and Peter, I don't know if you saw this. It was a couple of Sundays ago. There's a weekly feature in the Ottawa Citizen with where it's called 1 in a Million, or I guess in this case 2 in a Million. And they portrayed Deborah and Peter and how they met through the RASC, and how they had similar interests in flying and astronomy. And it's a really well-written article. Just out of curiosity, who all saw this? So quite a few of us saw it. It was a one-page spread, and it was really well done. And I really love how the RASC was promoted really nicely. You know, it just dawned on me, I jumped over something. We always like to welcome new folks to the meeting here. Just maybe raise your hands. Who's new here the first time tonight? Well, that's just terrific. Welcome. We love having you. We got a lot going on in our Ottawa chapter, the RASC. We got a table outside, and we can talk all about what we have to offer beyond the monthly meetings here. We're very active. We'd like to be active in the community, and I'd love to talk to you more about that, because we'd love for you to be involved with this. But it's great that you can join us. Another one, Sky News photo of the week. So this is a photo of the 3 stars taken by Orion's belt, taken by 1, 2, 3, obviously. Taken by Sanjeev at Nirvana a couple of weeks ago. You said, Sanjeev?
Last year.
Oh, okay. More than a couple of weeks ago. And so Sanjeev said he's going to tell you a few things about it when he's going to be up a little bit later on to talk about one of his photos that he's sharing with us later on. So, but well done, Sanjeev. And I have to say that I've been watching Sanjeev's work over the last couple of months, a year or two, and it's really inspirational to see his progression, because it's something I can look forward to and so forth. So Deborah and Peter, I just saw you come in. We have a. Can I go back one slide?
Yeah, you can go back.
How do I do that?
Other button on the left.
Oh, thanks. Recognize this from the 1 in a Million or 2 million feature. Excellent, wonderful article. Great promotion. No. Starstruck lovers. Yeah, okay. Wonderful promotion for the RASC. So it was really nicely done. Well done. Good for you.
You're up.
Yes, good evening, everybody. And okay, my clicker. Thank you. So to start tonight, we have a all-star program, and to kick that off, we'll do that with a planet. And yes, I'm not... the reason is simple, is this planet was once a star not that long ago, and that justifies my all-star title for tonight. The other ones will be stars, real ones, I promise, still. Now, this has transformed into a planet made of solid diamond. With a title like this, the news has been spreading a lot, even to Journal de Montréal on the August 29th. Unfortunately, nothing was really explained properly, so I'm sure that a lot of women have been thinking that it would be an opportunity of a lifetime. I doubt it. So let's get the full story here. This diamond planet is orbiting a millisecond pulsar, and they are about 4,000 light years away from us in the constellation of Serpents. So it's not tomorrow that we're going to go get those diamonds. The system was detected by the 64-meter radio telescope in Australia because the pulsars emit a beam of radio wave as they spin. Now, the arrival time of those radio waves pulses were modulated every 130 minutes. Therefore, the international team of scientists concluded that this pulsar is gravitationally pulled, that one word I couldn't say, back and forth by a small orbiting companion, a planet. This planet orbits the pulsar in just under 3 hours. Sorry. How do I go back?
Backwards, or I'll do that.
Oh, thank you. Wrong button. So the planet is here, and it's orbiting that pulsar here in the middle. And like I said, in just under 3 hours, and the distance between the two objects is a little less than the radius of the sun, so that yellow circle here would be the radius of the sun. Just to keep things in perspective, obviously the sun is not there at all. The team thinks that that planet is a tiny core that remains of a once massive star whose material was consumed by the pulsar's gravity. And this mass transfer is what would explain that the pulsar gets into very high spin. Now, what's left of that star is largely carbon and oxygen. Lighter elements like hydrogen and helium just wouldn't fit the model. And the density means that this is more in a crystalline structure, and therefore they said that the composition is similar to diamond. And they guess, that's a guess, obviously. Next is the star that's metal poor and that should not exist. This faint star is in the constellation, but it's there. It is in the constellation of Leo the Lion and has the lowest amount of elements heavier than helium or metals compared to all the stars that have been studied so far. And its mass is less than our sun, and it's probably about 13 billion years old, so that's one of the oldest stars ever found. Theory predicts that a star with such a low mass and low quantity of metal should not exist because the clouds of material which that star would have come from would not have condensed. And that means that the scientists will have to revisit their theory because this star obviously does not fit it. So here's a little more if we go back to the Big Bang. So shortly after the Big Bang, light chemicals, light elements like hydrogen and helium and a bit of lithium were created right after the Big Bang. All the other elements were formed later in the stars. So the first stars that formed were with lighter elements. Then supernova's explosion spread the heavier elements that were generated or formed in the stars later into the interstellar medium, then making again it richer in metal, and then the new stars that would form will have heavier metals in them. Basically now you can see that the proportion of metal in a star can tell you how old it is, depending if it's formed right after the Big Bang or later on. So this old middle poor star should have had a little bit more lithium, about 50 times more than what it had, just to match the material that was available when it formed just after the Big Bang. Again, doesn't work. Also, in theory, a star with such a low mass should have been forming more after a supernova explosion with some enriched stellar medium, which it doesn't seem it has. Anyway, beside the fact that nothing works and that star should not exist, it is there, and it's said to be too faint to be seen through most of the largest amateur telescope. So here's the challenge for the observer in the crowd who have the big telescope. Why don't you go observe this star and bring us a picture, another one beside this one. Next up for grab. Now we go from all that to a cold star. Excuse me. Scientists have been using NASA's Wide Field Infrared Survey Explorer, or WISE, and with the data they have discovered this new class of cold star-like bodies, like this little green fellow in here in this picture, with temperature as cold as the human body, and this is a star. These stars are also called white dwarf, and they are part of the brown dwarf family, and they are difficult to see in the visible spectrum, but with instruments like WISE, we can finally spot that faint glow of those white dwarfs. And just to give you an idea, they are mostly between 9 and 40 light years away from us. And these white dwarfs are about 5,000 times brighter at longer infrared wavelength, and that's why we need the Space Telescope in the infrared to see them. Not surprising, all brown dwarfs are also called fail stars, and they are too low in mass to fuse atoms, thus not burning with fire in the visible spectrum, or not for long, and eventually the light they emit is eventually just in the infrared. So far, WISE has revealed about 100 of these new brown dwarfs, and 6 of them are in the white category. But there are more to come. WISE has scanned the sky about 1.5 times, so there's a lot of data that the scientists have not had time yet to look into, and once they do, they may find more. And to give you an idea, the normal non-white brown dwarfs, are most likely around the temperature of your oven, 450 Fahrenheit. But with the WISE, we're moving out of the kitchen's oven and into the colder part of the house because it can be, like I said, temperature of the human body. So we're looking at 80 Fahrenheit, 90. Now you may ask, why is this interesting, this really not very hot star? Well, it is because astronomers can study those brown dwarfs to better understand how the stars form and understand the atmospheres of planets beyond our solar system. The atmospheres of those brown dwarfs are very similar to those of the gas giants like Jupiter, but they are much easier to observe because, contrary to Jupiter or any other hot gas planet, they are alone in space, away from a blinding light of their parent star. So I've talked about WISE as an instrument to actually find out about these brown dwarfs, and then I asked myself the question, what about Spitzer? And basically, so what they do, they take the data from WISE to get a candidate list, and with Spitzer, they narrow it down to what can still possibly be those brown dwarfs, and eventually they need to confirm those candidates with some powerful telescopes on Earth to look at the molecular signature. So I think this is interesting because the visible and ground-based telescope, they cannot be used to find them, but once you know where they are, you can use these telescopes to confirm their identity. That was a artist's concept of what a brown dwarf could look like. So in the end, he thinks it's purple. Maybe he was colorblind, I don't know. This is something. I've been recently stuck in my car for several hours driving my son to summer camps here in Ottawa. And from where I live, it's about, an hour away from home. So round trip, 2.5 hours each day on the road. And that would have been very boring except for the fact that I started listening to these astronomy podcasts. They're made by a non-profit educational resource, and they're provided by Fraser Kane of Universe Today and Dr. Pamela Gay, a professor at Southern Illinois University. As well, they have support from Swinburne University, who provides also the Astronomy Online degrees, if you ever heard of them.
Swinburne.
Yes?
That's the university in Australia.
Yes, it is. So I've known about this for a while now, but I've been holding off suggesting it to you because I hadn't had the time to listen to many. But now, I've listened to quite a number of them, and I really enjoy it. After 5 years of publishing, they literally have hundreds of those episodes to choose from. These podcasts can be found on iTunes. You can download them, put them on your iPod, iPad, iPhone, computer, whatever. iPod in my case in my car. And or you can listen to them directly from the astronomycast.com website. Voila, this is it for tonight.
So up next is Gary Boyle talking about the September skies and what we can expect.
Thank you, Mike. Good evening, everyone. If we move to the first slide for the cloudy sky report, rather than clear nights, because you can see we only had 2 good nights from August 5th to September 6th, and you can see the data. I do take records every night, even if it's cloudy, write down as an observation, just really could not observe. So hopefully things will get better. Speaking of which, tonight, extremely clear, and tomorrow night there's a high transparency alert. Not a bad thing, alert, it's a good thing. High transparency being 5 out of 5. For once, the jet stream is not moving over Ottawa, so it'll be great for planetary and lunar photography. So keep that in mind because it's full moon on the 12th, but even though if you do want to image Jupiter, should be a good night tomorrow night. Right, Rolf? We'll see. Okay, so some things in the sky. First thing, when sun sets, we get the beautiful Milky Way overhead. We have Cygnus the Swan, along with Lyra the Harp, and Aquila the Eagle, which makes the summer triangle. So we have that for another couple of months, but if you're so inclined to look at the Milky Way, it's directly overhead. Perfect night, nice cool night, so it's a real treat. You can see we do have an interstellar visitor over here, Comet Garrod. Who has seen Comet Garrod? Good, excellent. So it's well placed in the sky. In fact, there are 4 comets that are visible, 3 of which are too close to the sun to be seen, mostly in the morning. So Garrod is the only one that's giving a good show, and will continue to give a show right up until February of 2012. Next slide, please. So here we have, again, Cygnus and Hercules. A lot of, there's M92 over here, nice globular cluster, especially M13. But for those, even with binoculars or good binoculars or a small telescope, Alberio is a beautiful double star. The 2 contrasting colors of yellow and bluish, or yellow and purple, everyone kind of has a little tinge depending on their eye. And of course the ring nebula M52. This globular cluster M56 is pretty faint. It's not as great as M13, but it's still a cluster. So there's a lot of work to do even with binoculars. And of course here is the actual path of Garrod. Of course, it was cloudy. The night was right under the upside-down coat hanger, which is unfortunate. But throughout time, it'll just get brighter and brighter. Next slide, please. In fact, someone did take, I did not take this picture, but someone else, I just got off the net. Unfortunately, I didn't put the credit. Anyone here took this picture? So I'm sorry I didn't put your name on there. But I did take a picture similar like this. Garrod is up here, but not as good. And here we have M71, beautiful open cluster in Sagitta. So Garrod is brightening. It has a semi-good tail, but it's mostly coma for now. Next slide. And other than the comet, we do get some surprises at night. Last month, or 2 months ago, in fact back in June, we had the supernova in M51. now the supernova in M101. And M101 is nicely placed just above Ursa Major, or the Big Dipper, the Big Bear. And just take Alcor Mizar and follow these 4 stars to get to the nice Phaethon galaxy. Next picture, please. And there we have when it was almost, the night before it was actually identified, the night of, and night after. So it's brightening quite nice. I don't think it'll be a naked eye for sure, but hopefully as bright as M51, if not brighter.
Is this your photo here?
No, it's not my photo. Again, off the net. Next slide. Unfortunately, M101 is actually behind my observatory. I can't even get to see it, so I'll have to rely on Joe. Joe Bonner just got his new 8-inch Meade telescope, so we're hopefully going to try it after the night tonight. And of course, it's that time of year when Orion the Hunter, the winter constellations are slowly coming up. This is around 3 o'clock in the morning. Of course, the sky moves 4 minutes earlier each night or each morning. So as time goes on, after a week, it rises a half an hour, and actually 2 hours after a month. And in winter, if you are so inclined to observe winter constellations, get them out of the way now before you're into the depth of minus 20, minus 30 degree weather, but still kind of low in the sky. So you might want to wait later on. Next slide, please. And just the where the planets are right now. Mercury is in Leo. It's just near, in fact, just a couple of days ago, it was right next to Regulus. Venus is cropping up. We'll see a slide coming up very soon. Finally, the red planet Mars is starting to show its face, and Rolf should be imaging pretty soon on that, but it's semi-far. And it's almost forming a straight line with Castor-Pollux in Gemini. Jupiter, visible all night, as I mentioned. Tomorrow night should be a great night to image it. It's the bright object in the eastern sky. Who has never seen Jupiter? No. Through a telescope. Have you seen it in the sky, though? Have you seen a very bright star in the eastern sky about 10 o'clock at night? Extremely bright. That is the planet Jupiter. We say bye-bye to Saturn. Saturn is on the western horizon, slowly moving down that 4 minutes each day. And Uranus and Neptune, again, not too much to look at, but it's in the evening sky. Next slide, please. And here we have just the various data for the lunar phase and the times if you're so inclined to follow whatever it is you follow with the moon. And we have the harvest moon coming up in a couple of days. I think that's it. Thank you.
Nope.
One more. For that segment. And I do have the, Sylvie has my tickets. Sylvie, you have my tickets? For the dinner? Yeah, Sylvie has my tickets. Sylvie, you just gave a great talk a few minutes ago, has graciously printed off the 100 tickets that we need for the annual dinner. So come see me during the break or after the meeting in the back of the auditorium, or in fact in front here is even better. Our special guest will be Dr. David Saint-Jacques, and he's with the Canadian Space Agency. A wannabe astronaut. Hopefully he'll fly soon. Tickets are $42 per person. Fantastic meal. Next slide, please. Fantastic meal, fantastic talk, and it should be a great night for sure. So $42 cash, or we do take a personal check made out to the Ottawa Center of the RASC. And people that have been to meetings in the past have really attested to the fine food. As you can see, this did not come overnight. Fantastic. These are actually culinary students, second and third year students. The meal is fantastic, just fantastic. So it's well worth the price just for admission. And it's a buffet. You can have 2, 3, 4 plates until they run out. And I think that's it. Now I'm out of here. Thanks, folks.
Thank you, Gary. For those of you who don't know, Gary runs a monthly sky feature out of the national RASC website as well. So I appreciate you doing this, Gary, and it's also interesting reading on his on the national website, www.rasc.ca. Up next is Eric, and he'll talk to you about his recent expedition.
Hi, everyone. Hope you had a great summer. In July, I brought my family on a canoe camping trip in Algonquin Park. It's something I'd always wanted to do. Actually, load everything up in the canoe, go find a camping spot, and stay there for a few days and camp that way. There's nothing like getting off the roads. On our way, though, we stopped at the Brent Crater, which is on the road on the north end of the park. If we can go to the next slide, please. This is a photo I took of the crater last year. And was it last year already?
Already.
Wow.
A couple of weeks ago.
Took this picture and where's the laser pointer? Thing?
Right there.
There we go.
Center button.
Center button, okay. So this is the crater here, the Brent crater. Took this photo when Chuck and I did our aerial exploration. And this is Cedar Lake here where we went camping.
That's a snow squall over there.
Yes, this is actually snow in the air. This photo was taken in August of last year, and we were treated to that. So the crater is about 3.5 kilometers in diameter. It has two distinct lakes, Tecumseh and Gilmore, and I always forget which one is which. And the way you get into the crater is the road that actually goes to Cedar Lake here. There's a little path that goes down to the crater, and it's about half a mile portage. Chuck and I actually portaged into this crater in 2007 with our canoe and did a trek like this, and we found some, I won't actually point out where the breccia is because we want to keep it our own, but there's breccia in here that no one else had ever seen. Right, Chuck?
Right on.
Yeah. I almost gave it away, but I won't. So this is the crater here, and the road comes in from the north. If you take Highway 17 north, heading towards North Bay, there's a turnoff to the park at a place called Two Rivers. And so you go down the road, you're heading south from the 17, and it takes about half an hour, and it's well worth going to because you'll be able to see this crater from the ground with a view that I actually prefer out of all three ways I've seen the crater. I've seen it from the air, we've gone into it, and the view that we get from the newly built lookout tower is actually my favorite because you can take all the time you want to study it. When you're in the air, you gotta keep moving around. And when you're in it, you don't really see that you're in a crater. But from, if we can go to the next slide, please. Okay, sorry, this is another aerial view of where you take in to get into the crater from the trail. The trail is somewhere in here. Next slide, please. So this is the lookout tower that you'll see from the on the side of the road.
Not high enough.
It's actually built just high enough for you to see the crater. If they wanted to build a CN Tower version, you'd get a much better view, but I don't think they have the budget for it. And there's a little spot on the side here where you can pick up a pamphlet that gives a lot of interesting information. It's the same pamphlet we've had for the last few years, but they keep reprinting it, but that gives enough information about what it is. Let's go to the next slide. So this is the view from the tower, and you can see the road down at the bottom here. And the crater this is actually the far side of the crater on the opposite end. So you need to take time to understand what you're looking at. If we could go to the next slide. So I've panned right, and this is the center portion of the crater. This is Tecumseh Lake, and the trail actually comes off this side and gets in there. If you want to take a little walk into the crater, you can do that. It's about 20 minutes to walk down to the marsh from there. Next slide, please. And this is the far right view. We're on the east side of the crater, looking west. And again, that's another view of the lake. This lake is visible. The other one is not from the tower. But here we distinctly see the far rim, and we're actually on the rim of the crater on the east side where the road is. And as you walk down the trail, you're actually walking down into the crater, and it's a bowl shape. You can definitely feel it as you walk down. Next slide, please. And there's a bit more of a close-up of view. So we have an excellent view of the other side of the rim in here. And for me, I think I appreciated seeing it more than most people would because I've seen it from other angles, including the air. But this angle here really spelled it out for me, and it reminded me a bit of my trip to the Chubb crater in northern Quebec, minus the trees, because it's about the same size as the Chubb crater, and it gave me that same feeling. Next slide, please. And again, a close-up view of the far side of the rim. You see it very well in here. The Brent crater is probably the most accessible crater you can find. Most craters that we've gone to, Chuck and I, took a while to get to one way or another. In some cases, it's very expensive to get to. But if you want to see a real impact crater, this is a good place to start. Is there another slide? Okay, so that's the last slide. My lasting memory of this trip to the crater is spending time with my daughter on Cedar Lake exploring. And I taught her at least 3 things on this trip that I wanted to share with you. One was how to identify an impact crater. The next was how to fold a map. And the third was how to roast a marshmallow. All of which are equally important. Thank you. Does anyone have any questions? Yes.
Yeah, Eric, I was at the crater there on the July 1st weekend, coming back from northern Ontario. And I agree that the tower that's there, I was surprised in a sense at how short it seemed. I thought even if, and when I got up there, the view was actually not too bad, but I was thinking another 15 feet of elevation would have been just fantastic. The road coming in, if you're coming from the north, dropping down from Highway 17, it's 32 kilometers in on this very dusty road. I ended up with more dust in my trunk than I think there is dust in the Sahara Desert.
Yeah, it takes about half an hour to get down to that tower. I don't know how much more of a view you would get, another 15 feet, or even if they doubled it in height, you know. But from that height, and also I forgot to photograph. There's a plaque on the on the tower right in front of you when you're looking, so you actually get to see what it's all about on this plaque. It's a very well done plaque that describes all the layers and how everything's laid out on the crater. So that helps a lot too. Great view, and I hope if you head out north on Highway 17, take the time to go and visit this place. It's well worth it. Thank you.
Thanks, Eric. I was looking at the audience during the presentation here, and I was noticing that some people were here from the, obviously quite a few people were here from previous meetings. And you remember the backyard EOS presentation that we had from Guylain Rocha? Guylain is here tonight, Guylain. And so remember that was a really interesting piece of software that he created that controls Canon software. So if anybody has any questions, you can probably nab them during the break. I'm sure he'd be happy to talk. Next up is a new fellow that I hope to be doing a lot of outreach work with, is Ryan Anderson. Now Ryan, I'm trying not to say too much about his presentation, but he works at Telstar, and he's got quite an interest in all things space, but he's going to talk a lot about satellites, in particular Canadian satellites. So Ryan, thanks for coming, I appreciate it. Thanks, Mike.
Thanks for having me. As you said, I'm Ryan Anderson. My question is, how do you fold a map, Eric? Thank goodness my phone has one on it. So I was asked to do a talk, and I thought I like Canada and I like satellites, so I'll talk about Canadian satellites. Turns out there's more than I can probably cover in sufficient detail in about 15 or 20 minutes, but I'll gloss over kind of the top level and kind of give you a taste of how many there are and what they're doing up there. Are you guys, do I have one of these?
Yep. The right button or center for laser.
That forward, that back?
Yep.
All right, so I kind of categorized the current Canadian fleet into 3 areas. Communications is far and away the largest, and it's what I do at Telesat. With Canada being so large, so sparsely populated, it's just the most economical way for us to reach across the country and broadcast to as many people as possible with as little, they're expensive, but as little cost as possible. So up at the geostationary orbit, we currently have about 13 Canadian-owned satellites transmitting over North and South America, Central America, and even some sort of international out over Africa and connecting Europe. Anik F1, the Anik name is actually has an Ottawa link. It was an Ottawa woman who won the naming contest. Anik is an Inuit word meaning little brother, and they put it out to a contest and she won. Just gonna kind of gloss quickly here. Anik F1 and Anik F2, both built by Boeing Space Systems or Hughes back in one time. You see in the picture, there's kind of two. You see the plain solar arrays. That's kind of just the general configuration. Anik F1 and a couple other of these 702 satellites had these extra panels on the wings, and those were concentrators, and they were meant to focus more sunlight onto the solar panels to increase the power. And it turns out that it's really hard to keep those in place, and the thermal shock from going into and out of eclipses tends to snap those. There's some hold downs for those concentrators, snaps them, and they actually cover the solar panels and end up doing the opposite of what we want them to. So Anik F1 is losing power in chunks every once in a while, and Anik F2 is there and happily powered away. Anik F2 happens to be the most powerful communication satellite ever built. At 16 kilowatts, it just narrowly edges the recently launched Telstar satellite, which is about 15.8. Anik F1R, Anik F3, and Nimiq 4 are three basically serving direct broadcast satellite your dishes at home. They were all built by Astrium. There's a set of regulations that came into play from the U.S. after the 9/11 disaster called ITAR, and it makes it very difficult for foreign nationals to get information about things like satellites. So Telesat decided we're going to go buy from the Europeans and get all the information we want. So those three satellites are all built by Astrium and owned by Telesat. Nimiq 1 and Nimiq 2. How many people have a Bell satellite dish? Does it ever go out on you? It's these guys' fault.
Shoot it down.
My very first project at Telesat was to automate the maneuver on Nimiq 1. Now the maneuver is about the most complex thing we can do on the satellite, and I'm sitting there all excited, and the flight dynamics analyst turns to me and says, "Did you program this like your job depends on it? Because it does." Nimiq 1 and Bell are far and away our largest customers at Telesat. I'm still there, so it went okay. Nimiq 4, again, is another Bell satellite providing direct broadcast satellite TV. Nimiq 5 was supposed to service Bell, but a company called EchoStar came in and leased the rights, made them a good offer, and they decided to let up. Nimiq 5 is also the first Telesat satellite purchased under the new ownership arrangement. So it's a company called Space Systems Loral that owns Telesat now, and we somehow keep buying their satellites, but don't know how that works. Telstar 11N. The Telstar satellites are all owned by Telesat. It's a name that comes from a company called Skynet, which was merged with Telesat when they were sold. Skynet and Telstar 1 are the first geocommunications satellites. So there's a lot of history that kind of got rolled into a Canadian company with this. So we're really excited to have a satellite and a program like Telstar. Telstar's 12 is one of the older legacy Skynet satellites. CL2, Telesat's not the only player in Canada. they were for a very long time, and in 2008, the Ciel group launched the Ciel 2, and we're waiting for more from them. The Thales Alenia bus I'm not quite familiar with, but this is apparently their largest, their Thales Thales Alenia out of Spain and Europe. MSAT 1 and 2. This company has gone through a lot of name changes. They might have been MSV, MSLVP, SkyTerra. They're now called Light Squared. The original MSAT 1 and 2, yeah, they should be toast. I was going to say, they're 1995 and 1996. They've now exceeded their design life by a good 3 or 4 years, and they're still kind of ticking around, but their replacements are on the way. These guys are mobile satellite communications. So they've got the rooftop sets on the cars, and they have mobile stations that they sell to emergency services. And the reports are that the MSAT service was the far and away best service during the Katrina disaster. They're the most reliable satellite communications through that. So these guys being at the end of their life, they contracted for 2 new satellites called SkyTerra 1 and SkyTerra 2. SkyTerra 1 was launched late last year, and you can see this big dish here. It is the largest reflector on orbit right now. It's a 22-meter reflector. Yeah. The previous the benchmark setting was an 18-meter reflector that came out no problem. They were worried about this, and it took a couple of weeks, and they actually had to knock the satellite back and forth to try and wiggle it out. It's an operation they call a shake and bake. They fire thrusters one way, then the other way, and try and point things to the sun and heat them up. And the reason for this big antenna is an amazing piece of engineering. Usually you have to point the dishes. So anybody who's got one of those satellite dishes, you got to point it, and you've got to get it set right exact. This has a set of software and hardware on board that can electronically steer the beams. So most of the other satellites I've showed so far have a set ground footprint. So if you move the satellite, the communication that you can reach and the power that you're going to get at different locations is going to be the same, just moved around. This can actually concentrate bandwidth to a certain area. So imagine a disaster like Katrina happening. They can take a spread out footprint, move a whole bunch of resources and capacity to one area to service a higher demand. Telstar 14R. This is the baby of the fleet right now. Telstar 14R was actually here at David Florida Laboratories last year for its thermal vacuum testing. It was launched in May, and the amazing story here is that it's replacing a satellite called Telstar 14, and the R is just replacement. Telstar 14 had a deployment anomaly on its north solar array. So Telstar 14 went through its entire life. It's just being deorbited now at half power. The requirements must have said, give us the exact same thing, because Telstar 14R, launched in May, also had a deployment anomaly on its north solar array. So it's at half power. Basically now it's kind of stuck, and we're hoping to still get 15 years out of it, and just enough power to kind of service the customers that are there. So we're sort of happy that we can do that, but it's sort of too bad that it's, again, just an amazing coincidence. This is one of my favorite pictures that Loral has ever released to us. I always think of RoboCop at the end of RoboCop, where he has to fight that big robot. Really rather menacing picture, but this is Telstar 14R in what's known as the compact antenna testing room at Space Systems Loral. Basically, really, you can kind of see a window off in the back here. There's another one kind of about where my hand would be, and sends signals to a reflector that's about where the sign down there would be, and it reflects them onto the antennas. And the antennas reflect back, and they can measure the pattern that the antennas are giving you. Just interesting, and I just love the picture. And here's Telstar 14R at David, Florida Laboratories. They're about to drop it into the big thermal vacuum testing chamber.
Which guy was
Drop.
responsible for that north panel?
Sorry?
Which guy in the picture was responsible for that north panel?
Yeah, it wasn't this guy right here, I'll tell you that. For some reference, here's a size comparison slide, just to kind of show you how large things are in relative size. So the one in the middle there is Anik F2. That height is 157 feet. So it's not tiny. The one on the right there with the large dish, that's a satellite called Telstar. That's that 18-meter unfurlable reflector. And then up in the corner, we're going to get to these guys right now, the Radarsat satellites. So I got two satellites in Earth observation, the Radarsat 1 and Radarsat 2. They're both, as their name gives away, radar satellites. They use C-band radio frequency to penetrate any kind of weather, hit the ground, reflect, collect, and give us an image of the ground. Both are.
Do they penetrate in the ground at all?
Not as far as I know. No, I've heard smatterings of people trying that, but nothing that I'm aware of. They are trying ground-moving target indication. They're trying to be able to use a couple of images taken rapidly back to back to see if there's something moving on the ground. Radarsat 2 gets about 3-meter resolution on the ground, which, as I understand, gave the U.S. quite a bit of a fright because it covers in about 8 orbits. Radarsat will cover every inch of the globe. So you'll get to see what's going on at least once every 8 orbits.
That's a day.
It's 100 minute orbit.
Yeah.
Yeah. So yeah, about a day.
Wow.
Yeah. Science satellites. So this is where my knowledge drops off quite a bit because these are all sort of new to me, but terribly interesting. The first 3 satellites, if I recall them correctly, these are also the only ones that are made in Canada. That was kind of neat. SciSat 1, atmospheric ozone and dust observations, low Earth orbit atmospheric measurements. CSA had Bristol build it out in Winnipeg, and they still, I haven't heard what they're doing lately, but apparently they're still building microsatellites at Bristol. This one really threw me for a loop. CanX, I don't know if anybody's heard of this, but talking about the communication satellites at 4,000 kilograms, 5,000 kilograms. This is 1 kilogram satellite. It's intended specifically to show that small satellites could operate and function in orbit. And it was it fits in a 10 centimeter cube and 1 kilogram. I don't know if it's still up there. I doubt it because it was launched in 2003. Polar orbits take a long time to decay. It could still be up there, but I have no idea if it's operational still. I just kept it up here because it was neat.
So Ryan, I was going to ask you, is there a relationship between the size and the amount of, and how long it can stay up there?
Is there a relationship between the size and how long it can stay up? Yes and no. The more size you have, the bigger batteries you can carry, the bigger panels you can put on, so you'll have power for longer. Your orbit determines your orbit and your fuel to determine how long you're going to really stay up. The orbits will decay, so you have to use fuel to boost the orbit back up. And once you've run out of fuel, it's just going to keep decaying until it burns up or not likely to splash down. But okay. CanX2 was a little bit larger than CanX1. Again, it's a demonstration mission to show that nano spacecraft can operate using small microelectronic type devices. It was launched at the same time, 2008, with this one called CanX6, also known as NTS Nano Satellite Tracking of Ships. Sorry, it's a ComDev initiative to use these small nano satellites and a constellation of them to detect ship traffic. And they've actually demonstrated that with this satellite that they can detect a ship, link it into a worldwide database of ship transponders, and identify what ship should be there or not. So they'd be able to identify a ship that isn't broadcasting its transponder and say, well, it's that's some sort of a rogue vessel or a pirate or something to look at. Very interesting concept. Hopefully we'll see more Canadian nano tracking satellites. And this last one here, you can probably ask the Ceravolos about this more than I do. I think they had a big hand in the instrument here, did they not? The only Canadian space telescope, and I don't know if there's any kind of a dollar for value satellite parameter, but this one might be right up there. I understand it's done a lot of really important astronomical observations. And that is the list. I've got just a last slide of what's coming up. Cassiope, SkyTerra 2, the bright constellation is actually, I said CanX 1, 2, and 6. Well, bright is CanX 4 and 5. Nimiq 6 is the next interesting one for Telesat. It's on its way to the David Florida Laboratories end of this month. And we'll see some more Radarsat constellation. The constellation will be kind of 3 satellites working in conjunction to provide even better resolution and repeated imaging. Polar communications and weather is another system that's been discussed widely. The geostationary communication satellites, if you just imagine trying to connect directly to the polar caps, it drops off over the horizon and it can't see the polar regions very well. So polar communications and weather is a system proposed to provide communications to the poles and do some weather observations while they're there. And then we'll leave those for future dates. Thanks, everybody.
A couple of questions.
Yep, I can take questions.
Do all of these satellites protect themselves automatically in the event of solar disturbances that you're getting these days?
Question.
Or do they have to be controlled from the ground?
All of them need some measure of control. When it comes to specific like solar flares or electromagnetic interference or discharges, the protection is to fully test them and sort of prevent the possibility of that happening or mitigate the possibility. So you radiation harden them and put them through extensive testing. The other sort of protection is redundancy. Our satellites, there's not a single point of failure on any of the large geosatellites in terms of electronics. Everything is backed up by two units for one needed or 3 for one needed, depending on the probability of those things experiencing a catastrophic failure.
Who launches the Canadian satellites, and do you ever go to see a launch? I notice you've got a couple of Russian launches there, the big Proton.
Yeah.
Do you ever get the privilege of going over there to see one of those big rockets going off?
Once I get VP behind my name, I might. So far, not. There are there are Telesat representatives at the launches. We have been using we have been exclusively using Protons, which are the Russians. It's the same rocket that was lifting Russian astronauts way back in the day too. So it's old technology. The guys say that Baikonur Cosmodrome, where they launch out of, is it probably hasn't changed in 50 years. But they're reliable. They're the best out there.
I have a question that's a little off, maybe. There was recently an article in the, I think it was the Sky Tonight or one of those things, saying about the garbage out there, the number of dead satellites flowing around and all this endangering all the other ones. Tell me, you're somebody that's in the business. Are you people beginning to think about clear-up?
We've been thinking about it longer than Sky News or any of the other media outlets. The geosynchronous arc is finite territory. We are acutely aware that if one of our satellites dies there, we can't use it anymore. The problem is it's just we can't bring them down. So we do everything we can to get them out of the geosynchronous arc and get them away from other geosynchronous satellites so that the world's communications don't go down. As far as all the other debris out there, it is a growing problem. There was a collision between a couple satellites a couple years ago, and the Chinese shot down a satellite a year or two ago, and those just create debris fields. There's a term given to some sort of an exponential growth. When you have a collision, that debris field spreads out, causes other collisions and other damage, and there's just a point of no return where it's just going to be an absolute mess if it doesn't get turned around.
There was a thing on the national.
Yeah, I think NASA or one of those organizations just released a big report on what to do. It's the difficulty.
About magnets, they were talking about actually physically going up and plucking them out of there.
Yeah, and it hasn't hit that price point yet, but at some point that will be such valuable territory that it'll be economically worthwhile to go up there, clear a spot, and come out.
Is there no international organization, sort of, international satellite commission or whatever?
Nope.
You know what I'm talking about?
There is not yet. There are groups that are trying to fill that role. There's I can't remember the name of the group at the UN, but the UN does look into it. It might be Copuous or they might have an orbital debris one now, but it is a growing issue and people are taking notice. We'll see.
Is that the largest one? They're bigger than school buses.
Well,
and the smallest are like little nuts and bolts.
Yeah.
They just hit. And the problem is when they collide, they just shatter into smaller pieces.
Exactly. But there you go. That's about the size of an ambulance. I mean, it's a big thing, but there's a lot of space out there too. So that's we've got this. The race is on. How much of the space we can take up.
Is the ISS the biggest satellite in space?
Absolutely. Yeah. It's like 3 football fields long. Yeah. It's enormous. The wingspan on it.
And one last question.
Which one was that?
The International Space Station. Yeah.
One last question in the back.
One on the back.
People are beginning to worry about the price of gasoline for their cars, and there are some concerns that there's a growing problem with supply of oil. Can you see a time when it will become prohibitively expensive to launch some of these satellites, and are people looking at conservation and how to launch with less fuel?
Absolutely. It's been prohibitively expensive to launch for a long time. The big launchers that do these geosatellite launches are heavily government subsidized, and they're throwbacks from the Cold War era where the biggest missile was the scariest kid on the block. We'll see if SpaceX, Elon Musk's company, can bring the cost down But if somebody comes up with a lower cost launch vehicle and lower cost orbital insertion, people are going to be all over it. It's $70 million for a launch right now. So yeah, it's if you can cut that by 10%, you'll have Telesat's business for sure. Yeah, great. Thanks everybody. Thanks.
Okay. I have one other thing I wanted to share with you, and we'll wait till the lights come on. I'm going to have to put the microphone down as I share this with you. So, if any member is interested, we have an RASC jacket. An Ottawa Center jacket here that we are in the process of developing. Now, it's customized for our center here, and you can see there's a little RASC logo here. And what I'd like to do here is that this jacket here is about it's no more than $50. Prices will drop if there's more people interested. But I'm going to turn around here. I don't want anybody making any.
Oh! Do a walk for us, there, Mike. Walk across the runway there. Da 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 da. Turn around again. Hand on the hip. Hand on the hip. Woo!
Don't take it off.
Yeah. Don't take it off. Take it off.
Thank you very much. Okay.
Thanks. I was going to apologize for the one or two of you that were made there were a couple of remarks, but I guess there was quite a few more than one too. Anyhow, we do have this. We are, if you are interested in this jacket, come take a look at it. I'm trying to measure the interest here. So if this indeed does interest you, if it does,
are we talking about the jacket here?
you know, there are other things to do on a Friday night. Okay. All right, where was I? So if you are interested in the jacket, let me know. I just want to gauge what kind of interest there is, and you can also. This isn't the final design yet. Somebody's taking a picture in the back. This isn't the final design. So if you're interested in influencing design, then I think it would be good if you come forward. So please let me know at the break if this interests you and so forth. Again, price no more than $50. Okay, on to the next segment here. So Al's going to talk about membership recognition. Thank you.
Hello and welcome. I'm the president of our club here in Ottawa, and as one of the things I'd like to do in my presidency is to recognize a little bit more of the members. This is a volunteer club, and it works on the backs of the volunteers like Mike and Chris and all the people that help put together these presentations. And as part of it, what I'd like to do is recognize members for some of their membership. We've had people that have been members of this club for 50, 60 years. And a lot of us probably don't even know these people. Several of us has only been around for less than 10 years, or even new people. So I thought I would institute a program where we actually make some lapel pins to recognize people who have been long-standing members and who have contributed to the service of the club. We do support a lot of awards as a club, as a society. And a lot of them are aimed at excellence in astronomy or dedication to astronomy as a hobby. But because it's a volunteer organization, I want to recognize the service that people put in as volunteers. So over the next few meetings, I'm going to recognize a few of these different groups amongst the members, and I've had some pins, some neat little lapel pins made up. And what I want to do this meeting is to recognize people who have had service awards, both national service awards and Ottawa Centre service awards that are still members. And so what I'll do is I'll read a brief little bit about the people that have got these awards. And you can see these are the current members who have received both National Service Awards and Ottawa Centre Service Awards. And if you're here, you can come up and I'll give you a pin. And if not, we can send them out in the mail. First, Dr. Ian Halliday, surprisingly, he's the senior member, I guess, of our club. He's been a member for 60 years. Joined in 1940, over 60 years, joined in 1949. Dr. Halliday is an accomplished and recognized professional astronomer, has been an RASC member since 1949. He received a National Service Award in 1974 for his service as assistant editor and then editor of the RASC Journal for the preceding 10 years. He served for many years as our representative on the National Council and was known for his popular talks in centers across the country. So I dropped off his service pin and his 60-year pin on the way to the meeting this evening. He lives in Ottawa. He doesn't come out to the meetings anymore, but he's still a member and loves to read the journal Astronotes. Dr. Lloyd Higgs is an accomplished and recognized professional astronomer, has been an Ottawa RASC member, joined in 1962, served the center as a counselor, treasurer, vice president, and then president in 1971 and 72, during which term the club's 16-inch reflecting telescope was commissioned. It's still actively used and is available for members' use at the Fred Lossing Observatory in Almont. Dr. Higgs was editor of the RASC Journal from 1976 to 1980 and contributed much of his astronomical work for publication. He received the National Service Award in 1983 for his dedication and now lives in Penticton, British Columbia. And I mailed him his service pin and his 50-year membership pin recently. Next on the list, Art Fraser. Art has been a member of the RASC since 1963 and has been membership administrator for the Ottawa Centre for the past 30 years. Together with his wife Anne, they have provided refreshments for our monthly meetings over that same period. Hopefully you can chat with Art on his centre memories after the meeting out in the foyer. He received a National Service Award for his dedication in 2004. Art, would you like to come up and get your pin? Thank you. Next on the list, Al Seaman. Al has been a member of the Ottawa Centre since 1997. He's shown superior dedication for his volunteer duties with the Ottawa Centre. Over a period of more than 10 years, Al served as director of our Fred Lossing Observatory out in Almont and was an important member of the SmartScope team, helped pioneer the creation of our centre website, and helped manage our membership and mailing lists on the internet. He's been a frequent traveler to the RASC General Assemblies, and for his continued presence as a driving force in the Ottawa Centre RASC, Al received the National Service Award in 2009. Now, he's not able to be with us this evening, but he said he should be coming to the annual dinner, so I'll be presenting his pin there. Next, Barry Matthews. Barry has been an RASC member in good standing for the better part of 4 decades. He's been an Ottawa Centre member on and off for more than 25 years, and also a Halifax Centre. He's occupied various roles in the Society, local, national, official, and even unofficial, at times heading endeavors, but more often laboring cooperatively in the background to further the organization. Barry's most widely known service to the RASC was his pivotal role in the early 70s in reviving the nearly defunct Halifax Centre. He also had a hand in the Centre's newsletter. While a member of Ottawa Centre, he was a regional newsletter in the late 70s to the early 80s of the National Newsletter, which is the predecessor to the current e-bulletin put out by the Society, and frequently served as the Ottawa Centre representative on National Council. At the Centre level, he was the recorder, the librarian, lunar and solar coordinator, and Centre councillor, was also responsible for completing the indexing of the Ottawa Centre's library, begun by the late Stan Mott, and named after Stan. Barry was one of the prime movers in the creation of the History Committee Office of the RASC Archivist, and has been chair of the Society's History Committee. In this role, he was pivotal in the preservation of the RASC library at the Canadian Science and Technology Museum here, and the formation of an RASC rare book collection within the RASC archives at National Office. He received his National Service Award in 2010. I don't know if Barry is here this evening. He does come out sometimes. But if not, we'll be sending him his pin when he is available. Okay. Now, on to Professor Rob Dick, who is a life member of the Society and has been in Ottawa Centre since 1968. Rob has served as our Centre representative on National Council for many years. Currently, he is working tirelessly in the fight against light pollution and has served as the National Light Pollution Abatement Chair since 2000. In this role, he authored the Parks Canada Guidelines for Outdoor Lighting and led the development of the RASC Dark Sky Preserve and Urban Star Park programs. For these contributions to our society, he was awarded a National Service Award earlier this year. Rob, can you come forward?
Thanks very much.
There you go, Rob.
Now on to our local centre awards. Stephen Nourse has been an Ottawa Centre member since 1993. During that time, he served as the Centre Treasurer for many years and continues to be an active contributor to the Smart Scope Remote Observatory project, as well as a sitting council member. Stephen received an Ottawa Service Award in 2007 for his dedication, and he said he wasn't able to be here to this meeting, but we'll be giving him his pin when he is available. Al Seaman, of course, received a Centre Award as well in 2007, but he's already been mentioned, so we'll only give him one pin. Next on the list, Chris Tarrant. Chris has been an Ottawa Centre member since 1999. He served as the Centre Secretary for many years and has been providing his time to help all the speakers build their presentations and support every meeting with his audiovisual wizardry. He received his Ottawa Centre Service Award in 2007. Chris? And last but certainly not least, Deb Ceravolo has been an Ottawa Centre member since 1995. She has served many volunteer roles, including national representative, councillor, vice president, and then president during the highly successful Ottawa General Assembly of 2006. Deb has been a leader in outreach and educational programs for our centre, and most recently she has served as the editor of Astronauts, a role from which she will be stepping down this year. She received her Ottawa Service Award for her valued contributions in 2008. Deb? Thank you. So thank you for your attention in this. The next, related to that last announcement, we're looking for a volunteer to take over from Deb as Astronauts editor. The benefits are adulation from the society, and if you do it long enough, you may get a pin. So please approach me or Deb afterwards if you have any questions about the workload and what you can do as editor. Please feel free to talk to Deb after the meeting. Thank you.
Thanks, Al. Okay, we've got quite a few observation reports here, so if for all of the observers, if you could line up on the side here, and we'll just do them one after another. So first up is Wayne Ross. Paul, obviously we can take you from the chair. But again, if everyone could line up on the side and we'll do them one after another. So John Wayne Ross. Is John here? Okay, let's...
and we'll skip over.
We'll move on to the next one then. That's kind of a shame because that was a wonderful... okay, we'll do John Wayne's next month. Actually, it's a really interesting picture he's got, so we'll keep you in suspense. Paul.
Yeah, this is AGC 0426. You remember last month I talked about George Abel, so I was unable to complete Able last month, and I'm finishing them off this month. This is AGC 426. It's a 3.3 minute shot. This is a galaxy cluster that's in Perseus. It's about 2 degrees east of Algol, you know, the demon star that's in Perseus, the Beta Persei. This is what I'm showing here, unfortunately. I have the depth with my telescope to go quite deep, but I haven't got the size. This is only the heart, the center of this galaxy cluster, a very famous one and quite a distance away. I don't know the exact distance, but something like 400 million light years away. These things are extremely large and extremely far away. And there's a lot of interest right now in these things because of the gases in them, the high temperature gases, and the question of what keeps them together. So next one, please. Now, this one is in Orion. It's called AGC 539. It's about 2 degrees west of Bellatrix. Bellatrix is the star in the shoulder of Orion, opposite to Betelgeuse. So, and this thing is also, this is a nice large one too. This one's a little dimmer than the other one, but this also is only the heart of these things. This is, of course, in the center. This is where all the action is. This is where all the recent studies have been about these galaxy clusters and about how they stick together and all this kind of stuff. This dates back to Zwicky and all those guys about dark matter and stuff like that. Apparently, dark matter permeates these things. So I thought I'd show these two to you tonight. Thanks.
Thank you, Bob.
Okay, ever since I came to Ottawa, I've noticed that quite often in the summertime, towards evening, there's been some thunderstorms that have rolled down the valley, and sure enough, once they pass, the sun comes out at just as it's setting, and quite often we have a nice rainbow. And so on I think it was the 19th of August, I looked out my back window and there was a nice rainbow, so I thought I'd get a shot of it. Particularly since last month, Rolf showed a moon over some cows. Well, I thought I'd then do a rainbow over some turkeys. Okay. So, now, could we go back to the first one?
Will the turkeys move like the cows do?
Okay.
The turkeys with the pea soup?
In the last few weeks, I've had a few turkeys visiting my place. So anyway, while we're on the subject of rainbow, I thought maybe I would mention a few facts that you may not be aware of. We all realize that the rainbow, you see the rainbow because of refraction through the raindrops, but you may not be aware of a few facts. Well, first of all, I'd like to point out there's a secondary rainbow you can just see on the top up there, and it's quite a bit fainter. And of course, the first one, the primary one, is about 42 degrees. The other one's about 50 degrees, and the colors are reversed on the secondary one. Okay. Now, the other thing that is perhaps not that noticeable in this particular picture is that between the two rainbows, it's darker. And that's known as Alexander's band. Alexander's dark band. No, he didn't play the trombone. However, we made this observation about 1,800 years ago. And it's due to the fact that the droplets, the angle at which they scatter light, they don't just scatter the colored ones you see, but also white light. And the angle is such that towards the inside of the rainbow, it scatters more light than outward. And since the other rainbow is reversed, it does the opposite, so it leaves a darker band in between the two. Okay, that's one. The other thing, if we go to the next one now. Yeah. The other thing you'll notice, most people have noticed, and I've noticed, that sometimes the rainbow, the downward part, is much, much brighter. And perhaps that's why some people think maybe there's gold down there because it's so bright. Well, there's not. You can see there's turkeys. Anyway, the reason for that is, I found out, is the raindrops consist of different sizes. The very small raindrops all that they're held together by the surface tension of the water, of course. Now the smaller ones are held more tightly. The larger ones, as the rain is falling, tend to get squished. So they're flattened like sort of like a pumpkin. And the large ones, because they're large, they produce a much brighter light, much brighter rainbow than the small ones. And the reason that you have it's brighter down more when you look more horizontally is because up there, the pumpkin shape, it just doesn't refract towards you as well. Whereas as it comes down, you see more of the spherical part, and the angle is right for you. So it's the bigger, brighter ones are down there, and hence it is brighter. Now I never knew that, so that's interesting. Now if you go to the very next one. Okay, now here, yes, you can see. Now below the rainbow, I intensified the contrast here. You can see below that, the rainbow, there's some bands, light and dark bands with it. And those are known as supernumerary bands. And that was one of the factors that a gentleman by the name of Tom Young used to explain or put forth the argument for the wave nature of light, because those apparently are caused in their explanation and their calculations by the refraction through the drops being such, there are different rays coming through, and some of them are refracted a little differently, and you get interference between the different angles and the different rays, so that you get where you have cancellation and where you get addition. So you end up with light and dark. So that was one of the arguments put forth for the wave nature of light. Okay? Now, going up in the sky, one of the things that, again, going out in my backyard one night, this was, I think, on the 19th? Anyway, what caught my eye was the fact that Jupiter was exactly, or the moon was exactly vertical from Jupiter. Now, I don't know if the ones in the back can see, but right down there is a little tiny dot. That's Jupiter. Now, I didn't, I guess I was too lazy to put in the background trees because I would need a different exposure for that. Now, this I took by, just with my little non-digital SLR, non-SLR digital camera, handheld. And when I looked at the image of Jupiter, I said, my gosh, it's not a little squiggly line like I usually get. So I enlarged the moon, and lo and behold, I got this beautiful picture of moon just with a handheld camera. I must have not had any coffee that night. It was so steady. Wow. Okay, that's about 10 times on my zoom on there. Okay, thank you.
Gordon? Good evening. Okay, this first one is M5. This was taken June 19th. It was also published on Astronomy Sketch of the Day, August 14th. It's done with a 200 mil Dob at 150x. And the thing that really struck me about this was, center one's the pointer?
Center's the laser.
Okay. Was this area right here, in averted vision, that was really just popping right out, and it gave a really three-dimensional effect. It was really quite striking. Okay, and next. This was a fun sketch to do. It was
was actually done in colored, the Saturn was done in colored pencil and then inverted, so I had to work in negative colors. And took a little experimenting to get it close, but the star down here is Porrima in Virgo, and that was Saturn's closest approach to it. Okay, next. This is not quite the same order I got them. Just bear with me a second. Okay, this is the comet Gerard. This is done on August 20th. Okay, and it's it took about 10 minutes to do the sketch. Again, it was done with a 200 mil Daub. Sorry, that's, I got two sketches here of the comet. That's the second one. And I'm telling you, but here's the first one. That was done on August 8th. Okay. Okay, next one. Yeah, that's the second one. Okay, and that one's the one that's done on August 20th. What caught my eye with this one is there was this little non-stellar object over here. This is the comet out here. But I was also picking up a non-stellar object over there. And the only thing that comes even close is NGC 6879, which is a Mag 11 planetary nebula in Sagitta. And I shouldn't be able to see that from my backyard with an 8-inch telescope. And I'm just opposite Place d'Orléans, so I got light pollution and galore. I don't know what it was, but it was there. Okay, next.
New comet, now lost.
Yeah, no, it's. I don't think it was a comet, but if it is, it's Webster 1. Okay. This is NGC 6818. This is the little gem in Sagittarius, planetary nebula. And what really pleased me was I was able to pick up the dark center on the planetary nebula and the slightly off-center star. And also it has sort of a bluish-green tint to it, which I know is really uncommon for planetary nebula, but there you go. Okay, and the next one. And we have the Veil Nebula. This is the only one. Oh yeah, NGC 6992 and 6995. Again, that's from my backyard in Orleans, using an 03 filter. But it's, maybe I'm getting better at it, but I can actually get them with an ultra-high contrast filter as well. And that's at 44x with a 150 mil refractor. Is that it? Nope. Oh, I got one more. RASC Cygni. Okay, a carbon star, and just a nice contrast. The red star, and it has a pale blue, and then sort of a regular colored star. It's a triple star. And that's it. Okay, thank you.
Hi everyone, my name is Shinya Sato, and I'd like to show you some pictures I took this summer. And this is a picture of the NGC 7000, North America Nebula. And I took 6 frames and stitched them together using the photo merge function in the Photoshop CS5. And the next slide, please. And this picture shows the location of the 6 frames. And for each frame, I took a 10 minutes exposure image. And next slide, please. And also, last July, I went to Florida to see the final space shuttle launch. And my viewing site was the just open space nearby the Space View Park. And the distance between the launch pad and my viewing site is about 20 kilometers. And I got to the site on the Thursday and stayed overnight and just wait for the lunch. And next, please. Yeah, this is a picture of the space shuttle launch taken from my viewing site. And actually, my wife took this picture with her Canon EOS XSI with telephoto zoom EF 100 to the 400. Thank you very much.
So thank you, Shinya. That was the first time Shinya has showed his pictures and images at this center here. So that's great. We look forward to seeing a lot more. Shinya, I was also at the, as I mentioned in the last meeting, at the to see the STS-135 launch, and I have to say I am downright jealous of the picture you've got here.
Yeah.
But I touched the orbiter. Did you? Okay. Next up is Rolf.
Okay, so this is the Milky Way, and it shows just about, you know, that projector is not in focus. Did anybody else notice that?
Yes.
Yeah, because those stars should be pretty sharp on the left as well. But
I can
actually,
assure you they're sharp on this screen, so it's not Rolf.
no, because even the writing in the lower left is pretty fuzzy. That's too bad. Anyway, so this is actually two images stitched together, and it goes on the left, just about from overhead to the horizon on the right, and I tilted it so you could get the whole thing in and get it a little bit bigger rather than have it vertical. And there's a lot of light pollution down at the bottom, so it's too bad, you know, that we have always. It's very difficult to find a spot where you can get right down to the horizon and get a dark sky. There's always light pollution, but some place like Nirvana might have better light pollution down near the horizon. But what I always find interesting in these pictures of the Milky Way is all the variety of colors in it. I mentioned this before. Still don't know what some of these colors are caused by, especially those kind of brownish orange colors in the middle. Anyway, okay, next. This is Jupiter. Well, actually, I guess I don't have to say that that's Jupiter, but anyway. And interesting to see those two reddish spots there in the north equatorial belt. It's upside down, so south is at the top, with the red spot in the south equatorial belt. As I mentioned before last year, the south equatorial belt was not present, so it disappeared last year and then it came back. And next, a few days later, the C14, and I guess I can advance it. There we go. So this is now with a 6-inch refractor, and it also shows the moon Io. You can see it moving. That's over the space of about 45 minutes. Okay, that's it.
Hi there, everybody. Got a few images for you tonight. I recently acquired a Mallancam Junior for showing live views of deep sky objects when I teach various astronomy and astro imaging courses. But I had a chance to do some imaging with it as well, and as it turns out, it's actually quite a capable little imager. Better than I thought it would be, and it's an interesting match for a Dobsonian. Typically, you don't do a lot of deep sky stuff with a Dobsonian because you get field rotation, but the Mallancam Junior is limited to about 4 seconds maximum exposure, and with software, obviously, if you catch a bunch of these images, you can derotate them using your software, so it gets around that problem. I've got a 12-inch motorized tracking Dobsonian, which I've put this on, and that even with the 4-second limitation on the exposure frames, that telescope seems to feed it a fair bit of light. So when I first tested it, this was my first test with that particular camera and telescope combination. So obviously the Ring Nebula there, and it managed to pull in a fairly decent image, considering this is only a stack of about 50 2-second images. So I've got the central 15.3 magnitude star there as well. One of the limitations of a Mallancam, and I know quite a few of you have them in the audience, is that essentially Mallancams are souped up standard definition video camera, and so the chip size is actually quite small. So whatever telescope you put it on, I mean, you're limited in your field of view, and it produces a physically small image. This one, in fact, I scaled this up about 50% just to show the details better in the nebula. But you're limited to relatively small image sizes. Next one, please. You can see that effect. Is that it? Oh, I'm flying, am I? Okay, all right. There we go. You can see that this is an actual image size, not scaled up at all. And I took this at Starfest a couple of weeks ago with the with the Malin cam sitting on the 12-inch Dob. So not a big field of view, but it cuts in pretty good and grabs a lot of detail in the dusk dark lanes and some of the brighter structures that you see there. Okay. This is actually an image of Comet Garrett, again taken at Starfest. There, I wanted to show you this because this is actually a sample of the. If you can run that, Chris, if you can click on that. This is a sample of short sample of the video, and you could see. Oops, sorry, did I do that?
Yep.
I did that. Sorry. Let's go back there. The laser's at the center.
Center.
Okay, so you can see just at the end of the sequence, it's coming out. There's a star coming out from behind it. This is actually about 8 minutes of motion, time lapse to about 12 seconds. And you can see the motion there. And it just loops itself over and again. So from this video, what I did is I extracted 36 frames, again at about 4 seconds each, so effectively about 3.5 minutes of exposure, and then took those individual frames and stacked them. So if you can freeze that one and go to the next one there, Chris. So you can see that when you do that, obviously you get rid of a lot of the video noise, and you get a lot more detail visible. You can see the tail faintly there as well, especially especially the coma there as well. So.
Oh, was this for your Malin cam as well?
Yes, it is. This is all with Malin cam, and it's a Malin cam Junior. There are, for those of you not familiar, there are different flavors of ROX Malin cam. Some of them will produce exposures several minutes or even hours long. This is a very small, all it does is 4 seconds maximum, up to 4 seconds maximum. And as I said, I really just wanted it for visual display purposes. But being into imaging, I can't resist taking images. So.
In the video we saw color, and we don't see color here. Is the color artificial in the video?
Not really. I mean, there's because the frames are short and it's essentially video. There's video color noise and things like that. But when you average them together, you get a truer rendition actually.
Okay.
So that's the Malin cam. This one here. Oh, what did I do there? See, too much power. I have too much power. Go to the yeah, you can go to that one. So one of the ways to get around the relatively small image size of the Malin cam is you can use a focal reducer on a telescope. That gives you a wider field of view, but it still produces a small image. The other way I like to do it is to make a mosaic of adjacent frames. So again, this is the Malin cam on the 12-inch. Each of these panels is about 127 individual images, about 4 seconds long each. So about 8.5 minutes of exposure for each panel. Then I just stitch them together to form a mosaic with a much larger field of view than an individual image would give you. So again, this is the Western Veil, the Witch's Broom. And the bright star in the center there, 52 Cygni, is not related to the supernova remnant at all. It's a foreground object. Next one, Chris. So this is the last Malin cam image I have to show you there. Again, just to give you an idea that it does not a bad job capturing some of the fine detail, given the fact that we're only dealing with 4 second long exposures. This particular one, again, stacked about 100 of those together to produce the final image. So the other thing I've been busy with this summer is getting away from the Malin cam is experimenting more with narrowband imaging. I've become quite interested in that. And for those of you that aren't familiar with that concept, narrowband imaging, this is an example of a broadband image. All the color images that you see are basically your camera is sampling all the visible light in red, green, and blue that's visible to the naked eye. With narrowband imaging, you use special filters, and you're only looking at small slices of the visible spectrum. specifically light from ionized hydrogen, sulfur, and oxygen atoms. Then you take those, you do that with a monochrome camera, so you take those 3 different monochrome images and map those colors into the red, green, and blue to produce a false color image. Next one, Chris. And that's the result of that. So the interesting thing with narrowband imaging is that it also tells you something about the object that you're looking at. Physically tells you something about the object that you're looking at in terms of where what's causing the emission of this light, what particular elements are causing the emission of the light. So it's in fact, this is the way a lot of the imaging from the Hubble Space Telescope is done. So the next one is a comparison. I did. There's my modest little effort up here, but this area here shows the Hubble of the same area there, and of course exquisite detail in the Hubble. But it's kind of neat for me to be able to relate what the Hubble sees to what I can produce with my little telescope on Earth. So it's kind of interesting. You can also, this particular image that I did mixes narrowband data, narrowband color data with broadband to give you the final result. You can also just produce an image using the narrowband, and they look kind of eerie, but they're kind of cool. Next one there, Chris. You can see it's certainly a bit of an eerie color there, but when you do just narrowband itself, it often increases the contrast difference between different structures in an object, and so it can reveal things that broadband doesn't necessarily show you as well. And you can really see that in my last slide here. This is what I'm currently working on. This is the Elephant's Trunk Nebula in IC 1396 up in Cepheus. So far, I've only captured the narrowband data. Again, you can see there's a fair bit of definition in the various clouds there as this thing's been boiled away. So I'm waiting for a good opportunity to capture the broadband stuff and mix it the way I did for the dumbbell, and I'll show you that at a later meeting. And,
Excuse me, can you tell us the color mapping that you're using?
yeah, it's using the Hubble palette. So the sulfur emissions are mapped to red. The hydrogen emissions are mapped to green, and the oxygen 3 is mapped to the blue.
Thank you.
You're welcome. Any other questions? No? Okay, that's it. Good thing. Thank you.
Is there a mic up here? Oh, this.
Yeah, but just talk
Oh.
to the podium.
To the podium?
Yeah.
Okay.
Yeah, we can hear you.
All right. Okay, well, I only brought 2 pictures because next month at the meeting, I'm going to give a presentation. So just want to show you a couple of pictures this time. So, as Gary said at the outset, there's a supernova in M101. And I had actually gone out and shot M101 July 3rd, July 4th, near on prior. And that's the image that you see on the left. That's with my 5.5-inch refractor. And that's 3.5 hours of exposures. And I had this image. It took me 2 nights to get the data because of the nights are very short that time of year, early July. And I used this it's an LRGB with H alpha. So you can see a lot of the H2 regions popping out. And that's the star forming regions in M101, and the H alpha. There's only 30 minutes of it, but it mixes it with the red, and that helps to bring out those H2 regions. So when the supernova news hit, I went back out, and this time I was at FLO, and this is on August 26th. This image here is just 1 hour of exposures through a luminance filter, and it's for the same telescope. And the camera here is my QSI 583 WS. Which actually I bought through the Cervolos about 1.5 years ago. And this, you can see that star there. It's not here in this image. And it was actually a lot brighter than I expected. I was kind of blinking these images for a good 15 minutes, and I thought, where is this thing? And it was right there. So that was August 26th. So I think that was a few days after they discovered it. And one of the interesting things about supernovas is that it's pretty much the only time you can resolve a star in another galaxy with amateur equipment, because typically we can't resolve stars in other galaxies. Now this particular star is over 20 million light years away, but so every other star you see in the image is a foreground star in our own galaxy, and this particular star is 20 million light years further away. So that's that. Now the next one I'm going to show you is actually a plug for my first solo art show. As some of you know, I've taken to life as an artist and a writer. And I'm actually now represented by a respectable art gallery in Ottawa, the Cube Gallery. And the Cube is in Westboro and Wellington Street. And they're going to host my first solo art show called Sanjeev Sivato Rasa, The Still of Night. And this show is going to start October 25th. It'll go on for 2 weeks. And I'm going to have about 25 to 30 of my pieces in the show. And they're all going to be printed on aluminum. I find aluminum to be a really wonderful material for astro images because the star fields really pop out. Now, the computer screen I find is really a very poor medium for showing images, and this screen as well is a very low resolution screen. But if you go and see these pieces, they're anywhere from 24 inches out to 60 inches in size. So you get to see some of my mosaics at the resolution that I intend to show. Now this particular one, and just another word about taking astrophotography into the fine art world. I personally don't know of anybody who has tried to take astrophotography into the world of fine art, into the world of galleries, at least not in Canada, and I don't know if there's people in the States that have done it. But the thing is that after you do photography of any sort, daytime photography or nighttime photography for 2 or 3 years, if you really work at it, I think pretty much anybody can take a good technical photo, an image that is well tracked, well focused, etc., and well composed. But to go into the art world, I think you have to also do something more than that, which is much harder, which is to tell a story. And I think that the night sky, a lot of people that do astrophotography are scientists and amateur astronomers. And we're quite interested in the science behind it and the detail, even though we recognize most of it's art, the manipulation that happens with the light that we gather through our cameras. But we still don't think of it, the night sky, we think of it mostly from a scientific standpoint. And I think there's a huge untapped area which has to do with the cultural significance of the night sky, which I think the cultural impact of the night sky has been far greater on the human consciousness than the scientific impact of the night sky. And this is what I hope to explore more fully. So that's just a little plug for the show. And October 30th, the Sunday afternoon, is the main vernissage, and it's again on Wellington Street. So I hope you'll be able to come out to that. Now next week, next month, I'm going to be giving a talk that's called Exploring Astrophotography as an Art Form. So I'll have a lot more to say about the directions that I'm taking. Any questions?
Thanks, Sanjeev. I'm back. Just one image. As you know, I do a lot of lunar photography with the TU cam, and I use the DSI black and white. But since I have a 10-inch Meade LX 400 ACF scope, which has dynamic optics, I trained it. I pecked at the periodic correction. I was still getting some little wibble wobble when I tried something with my DSLR, my 450D. But then I noticed on the keypad there's actually a precision tracking mode. And I was taking single images pinpoint with 40 seconds. So I just could not believe, I almost cried that night when I got pinpoint stars. So I actually took 30-second subs, and these are about 19 images used in Deep Sky Stacker, thanks to Deb. You mentioned it's better than Registax, and definitely for sure. So it's only about 9.5 minutes of exposures. Take it from Barhaven. I know I got a lot of work to do, more imagery to do on it, but it's a start. So hash around the idea of spending a few $1,000s on an S-Big camera. I think I might still work with the water fuel stuff, and we'll play it by ear. See what the CFO at home says on what I could buy. But for now, hopefully this will be a beginning of some nice wide angle stuff. Thank you.
The button there? Here. The width. Right here, right?
Yeah, that's backwards.
Forwards, right.
What's the other side?
Unlike Rolf's images, mine look better when they're slightly out of focus.
This is a picture of M101 that I took before the supernova, and this is after.
Oh.
So,
Wow.
can you spot the supernova? How about you, Deb?
Wow.
It was pretty bright the night I was out there. You will notice, by the way, that this has got more time on it than this image. Can you see the noise? Or is it so out of focus you can't see the noise? We haven't had a lot of clear weather this summer, so some of these images are much shorter exposures than I like. This is the Eagle. I would love to do some imaging in Sagittarius, which is down low in the south in the summer. And it's just too low in the sky for me to get it, but the Eagle was high enough that I don't know, maybe this is a 3/4 of an hour long of imaging on it. And you saw a picture of the dumbbell already tonight. And this is about an hour of it. And it was pretty much overhead, so I really had no excuse not for getting more time on it. But the red is the hydrogen gas being excited by the center star. And the blue-green is oxygen 3. And this is the Pac-Man. And I don't know how old you guys are, but Pac-Man certainly relates to my culture. And it was high in the sky too. And that's it. Thank you.
Okay, just because of the time, we're going to finish up right now. There's a couple of announcements. Al's presentation, we're going to move to the next meeting about the possibility of life on other planets. But a couple of announcements I want to make really quickly, then we'll wrap up. We received a note from the Kingston Center, I guess in the past day. They have the 50th anniversary dinner coming up on the October 22nd there. We've got a special guest speaker. And if you are interested, you can go on to the Kingston RASC website, kingston.rasc.ca, or you can contact Kim Hay, who's pretty prominent with the Kingston Center. If you want more details on this, come up afterwards, and we'll leave the slide up for you to look at. Next slide. Another thing that happens periodically is an astronomy course that Stephen McIntyre has presented in the past. Pat Brown and Peter Heyman are joining as well. This is there's a lot of work that's been put into this over the years, and it is a free a course. I know the work that Stephen has done in the past, and I'm sure Pat as well, and so on. And you're in for a treat. So if you're new to astronomy or you're interested in learning some more, this is really well done. Okay. Again, if you want more details on this, come back after the presentation and after the meeting, and I'll put this up here so you can look at it again. Estelle Rother runs. Our club has a astronomy library, which is actually just outside the door to the right here. It's currently managed by Estelle Rother, and Estelle has a pick of the month, higher than Everest. But the library will be open just after our meeting tonight. Again, it's just out the door here, just to the right. You can't miss it. Next slide. Okay. After the meeting, as I said, the library will be open. We also have, again, for people who are not familiar with our center, we also have as a benefit to members, is a telescope library. So it's a wonderful opportunity to, once again, as I said in the past, try before you buy. You'll notice as soon as you step outside the door, we've got coffee and drinks and conversation, courtesy of Art and Ann. There's also some information on membership outside. You'll see in all the membership benefits. Love to talk to you about it if you're interested, because there is a lot going on for our club, and certainly a lot that you can offer. We certainly can offer. I think the rest is straightforward. Rest of the museum is closed, as we usually always say. And then finally, there's a group that goes to Kelsey's. You're welcome to join us just up the road and carry on with the conversation. Tonight, there was 107 of us. Thank you so much for everyone who put so much time and effort into the presentations. They are terrific. I hope you enjoyed it. Maybe not too much, but I hope you enjoyed it. And thanks as always to the museum for allowing us to use the auditorium here. All right. Next meeting is in October, Friday, October the 7th. And
as well. And do we have one more slide? And don't forget, and what I said earlier, the Star Party at CARP, it's Saturday in a week, and hope to see you there. Hopefully the weather will cooperate this time. Thank you so much, everyone. Have a good evening.